Welcome back to Learning with me, Ms. Killen, here at MPB. We are starting Unit 8. Now, our Unit 8 is our exponential functions. Now, we have gone through this long list of functions already. We have our linear functions, our quadratic functions. Now we have gotten to the exponential functions. Now, before we can really get into this exponential functions, let's see what we got up here on the screen. So we're looking at Unit 8, which is exponential functions, but our Lesson 1, which is what we're in, is going to be our geometric sequences. We're looking at IF3, BF1, and LE2. I can find recursive and explicit formulas for geometric sequences. So let's go ahead and dive in and see what we've got. Now, I've got a sequence over here, and it has 3, 6, 12, and 24. So this is our sequence. Do I see a pattern? Now remember, with all these different sequences, when we had our arithmetics or our arithmetic sequences, we had patterns. Do you see a sequence of patterns here? I do. I see that if I multiply here by 2, I get 6. If I multiply here by 2, I get 12. And if I multiply here by 2, I would get 24. And just to keep this sequence going, if I multiplied again, I would get, you're right, 48. So when I see this sequence or this pattern, my pattern is multiplying by 2. That was a good catch. So let's see. It says this is called geometric sequence. Each term in the sequence is a product, very important, a product of a previous term and a real number. Just like when we did arithmetic or arithmetic sequences, we can make a table. So let's look at these. So here is our intro to this function notation. Remember, we have f of something when we were doing those linear, or f of something when we did those quadratics. Now that we're looking at the sequencing, we can also use that function notation. So let's go ahead and, if you want to, watch me fill in this table, and then you can fill in your notes page. First thing, I'm going to read this on the top, which says explicit formula of geometric sequences. This is our formula that we need to make sure that we write down and take note of. A sub n equals a sub 1 times r to the n minus 1 power. Now you're probably sitting here thinking, Ms. Killen, what does all that mean? Okay, so let's take some notes of what that means. Let's put this on our notes page or wherever you're taking your notes. So my a sub 1 is the nth term of the sequence, whatever we're looking for. That a sub 1 or subscript 1 is my first term. The r that we see, that's the common ratio, what I'm doing to go from term to term. And then the n is the term or the position of the sequence. So let's look at this table. My first term, which is my a sub 1, was 3. My second term, which is a sub 2, which is 6. My third term, which is a sub 3, which is 12. My fourth was 24, and then we found out that my fifth was 48. So let's see what that function notation looks like. I'm going to write it up here and see if you're starting to see the pattern. Here we go. So I'm going to write this as f of 1 equals a sub 1 times 2, 1 minus 1. And that equals, my first term was 3 times 2, 1 minus 1. Well, 1 minus 1 is what? That is 0. Anything to the 0 power is going to be 1. So I'm left with it equaling 3. That's how we look at that function notation. So let's write one for our second term. Here we go. Let me use a different color so we don't get them mixed up. So I'm looking for my second term. So I have f of 2. So that's going to be a sub 2 times 2 to the 2 minus 1 power, which that's going to be my a sub 2, excuse me, my a sub 1. That's what it should be, guys. I do apologize. I was thinking I was going to put my 2 as my exponent. So let me go ahead and erase this, and let me write it correctly. That's a sub 1 times that 2 to the 2 minus 1 power. That's where your 2 comes from. So that a sub 1 was our 3 times 2 to the 2 minus 1 power is what? 1. Anything to the 1 power is itself, so 3 times 2 equals 6. Good job. So let's get us another color. Let's do dark green. So let's do our third term. So we're looking at f of 3. So I have a sub 1 times 2 to the 3 minus 1 power, and that's going to look like a sub 1, where we started this sequence, was 3 times 2 to the 3 minus 1 would be 2 power. Obviously, 2 squared is 4. 3 times 4 is, you're right, it's 12. All right, so let's get another color. Let's look at purple. Let's do our fourth term. So we have f of 4 equals a sub 1 times 2 to the 4 minus 1 power, and that's going to look like a sub 1, which is where we start at 3, times 2 to the 4 minus 1 is the third power. So that's a calculator skill. I'm going to grab my calculator and I'm going to put exactly this in there, 3 times 2 to the third. So on your calculator you put it, I'm going to put it on my calculator and see what we got. So I put 3 times 2 exponent power 3, and I get, yep, 24. There we go. So let's get one more color. Let's do orange. So I'm going to do f of 5 equals a sub 1 times 2 to the 5 minus 1. So let's go ahead and write that. A sub 1 is where we started, was at 3, times 2 to the 4th power equals, again, I'm going to put it just like that in my calculator. I'm putting 3 times 2, remember our exponent key, to the 4th, and I get 48. So not only have I filled out my table, I've looked at my terms, I've looked at what they are as of sequences, and then I put my function notation or my f of n notation. All right, so let's see what else we got. All right, so it says we're going to process this like the arithmetic or the arithmetic. So let's see explicit process, where we go and relate back to the first term, so we can see through the graph an example to write an explicit formula. Now, we've done to here. So I'm going to start here and go to the 6th to the 10th power. So let's finish out this table from what we did for that 1 through 5 in our sequence. Let's do 6 through 10. So here we go. My 6th term would be a sub 6. So let's see. It's going to look like f of 6 equals a sub 1 times 2 to the n minus 1 equals, so I have 3 times 2 to the 6 minus 1, which is just like saying 3 times 2 to the 5th. I want you to plug that in your calculator. When you plug that in your calculator, what do you get? Exactly right. So let's put that. So I am going to have it equaling what? Not 48, but 96. So it's going to be my 96. Let's go to 7. All right. So here we go. So I'm looking at a sub 7, which is going to look like f of 7 equals a sub 1 times 2 to the n minus 1, which is the same as saying 3 times 2 to the 7 minus 1. All right, so that's also like saying 3 times 2 to the 6th. I'm going to plug that in to my calculator, and what do you get? 192. So here we go. We get 192. All right, let's do the next one. Whoops. So I've got a sub 8. So I have f of 8 equals a sub 1 times 2 to the n minus 1, which is just like saying 3 times 2 to the 8 minus 1. So I have 3 times 2 to the 7th. And what did we have that? Let's see. Let's plug that in. So I have 3 times 2 to the 7th, and I get 384. So I want to go back and double check that 7th term just to make sure that my calculator skills are right. So I'm going to go back and put that in. 3 times 2 to the 6th power, and I get 192. Exactly right. So let's do 9 and 10. I'm going to do it in real time up here. You do it on your paper. When you get done, look up here and check your work. So here we go. Okay, check my work, check your work. Did you get 768 and did you get 1,536? See what I did. Now, obviously I left this middle part out, but that's okay because it's the same thing that we've been doing. All right, it's the same thing we've been doing. So that's why I don't necessarily have anything right here. So we see through our chart that we are continuously increasing exponentially. All right, so let's look at the next one. All right, a recursive formula. Now we've done the explicit. Let's look at recursive formula. It expresses each term based on that one before it, okay? So a sub 1, which is our first term, and then we have a sub n, which is the term we're looking for. What we're going to take is our common ratio. Is how we're going from term to term. It's called the common ratio, and we're multiplying it by that previous term. So where a sub n is the nth term in the sequence, a sub 1's the first, r, like we said, was the common ratio, and n is the term or the position in the sequence. Some key points that we need to remember. You must define the first term as a sub 1. Otherwise, the recursive has no starting point. Recursive formulas are useful when you're computing terms one at a time, especially when we're dealing with computers and programming. Now, some of us may be looking at that information systems as something we want to do in college, or maybe computer programming. Even in our gaming systems, there's programming. So all of this has to do with that computer programming. So that's something to think about. Okay, this is also not as fast as the explicit formula when you want to jump straight to a high number like a sub 50. So let's look at this sequence, 5, 10, 20, 40, and 80. What do we see as our common ratio? How am I going from one number to the next? Exactly right, I'm multiplying by 2. So I can see that each time I multiply by 2 and I get the next term. So it does state that our a sub 1 equals 5. And so let's go ahead and fill out what we know. If I look for any term, I'm going to take that what? I'm going to take that 2 and then multiply it by the previous term is what I'm going to do. So this works, and it only works when our n is greater than 1. Only works when the n is greater than 1. All right? So let's see if we can find out what comes next after 80 just by using this. So I'm going to go ahead and write it up here. Let's get it in a different color so it can be different. So I have, let's see, this is the first, the second, the third, the fourth, the 5th. I'm looking for my 6th term. So 2 times, and I'm looking for a sub 5. And a sub 5 is 80, so 2 times 80. So my a sub 6, or my 6th term in this sequence, is going to be 160. And that's how we look at these recursive formulas. This is how we use them. So let's see what we got next. All right, answer the following questions about this sequence. -2, 4, -8, 16. What are the explicit or recursive formulas for the sequence? Find the 10th term in the sequence and solve for the 23rd, the 15th, and the 19th. All right, so let's do some practice. So I want you to go ahead and use this and see if you can figure out two things. One, what is your common ratio? That means what I'm using to go from one term to the next. And then see if you can write a formula that would help us find my, my next terms. So let's look. So let's see. I've got -2 to +4. So what would I do there? I'm thinking I would multiply by a -2. Now, let's see if that works for the next one, because it may just be a fluke. Let's see if it works for the next one. So 4, taking that same -2, if I multiplied it, I would then get a -8. So let's try it one more time. So if I multiply it by the -2, negative and negative is a positive, and 8 times 2 is 16. So obviously, I found my common ratio. So let's see if we can find our next term. Let's see. 16 times a -2 would give me a what? I think that's going to be, let me double check my math. Ms. Killen, you mean sometimes you have to use, yes, it's okay to check your math. Better to check your math twice than get it wrong once. So always check your math, even for the little things. That's okay. So we've found what our common ratio is. So I am looking for, I'm going to put my explicit. So I'm starting with a sub 1 times 2 to the n minus 1. Now, let's double check to see if that's the formula that's going to work. So here we go. Let's look, let's see, this is our first term, this is our second term, our third, our fourth. Let's see if we can find our a sub 4 or our fourth term. So a sub 1 is -2 times 2 to the 4 minus 1. 4 minus 1 is 3, so 2 times 2 to the third. I'm going to plug that into my calculator. So let's see. -2 times 2 to the third. Now, Ms. Killen, isn't that common ratio supposed to be a negative? You're exactly right. That's a good catch. So I'm going to multiply this times -2 to the third, and I get a positive 16. So our formula is conclusive that if I use that a sub n equals a sub 1 times a -2 to the n minus 1 power, it's going to work every single time. So with that in mind, let's go ahead and find this 10th term. All right, so I'm going to write it on the board. You work it on your paper. Let's see if we get the same thing. Here we go. So I'm looking for a sub 10 equals a sub 1 times -2 to the n minus 1. So I've got -2 times -2, 10 minus 1. -2 times -2 to the 9th. I'm going to plug it in my calculator just like that. -2 times -2 to the 9th. I got 1,024. What did you get? Good job. So I know that the 10th term of this sequence is 1,024. Now, go ahead and I'm going to let you work for just a minute and a half. Use the same formula. Find the 23rd term, the 15th term, and the 19th term, and come back to me and see what we got. Okay, so you've done your work. Let's see if I get the same thing you did. For my 23rd term, using a sub n equals a sub 1 times negative 2 to the n minus 1 term. For my 23rd term, I get negative 8,388,608. Don't you wish that was money? Don't you wish that was money and it wasn't negative? But I do get a negative 8 million. All right, so for the 15th term, for my 15th term, I got negative 32,768. Is that what you got? All right, let's do the last one. Let me get one more color. Let's get green. So my 19th term, I get negative 524,288. Ms. Killen, those are some really big numbers. Yes, it is. That's why it's good to have a formula to use instead of just having to multiply by negative 2, multiply, because you'd be here all day. So if we have a formula, then all we got to do is plug the numbers in that we're looking for, pick up the calculator, and we got it made. Good job. All right? So here's a skill that we're fixing to come up to that is going to help you either on this unit test, your mid-unit test, or even that test at the end of the year. So let's look. Answer the following questions about the sequence. What are the explicit recursive formulas of the sequence? Find the 10th term, the 23rd term, the 15th term, the 19th term. Now you're probably sitting there thinking, Ms. Killen, we've done this. Yes, we have. But now let's check our answers. So everybody pick up their calculator, and what we're going to do is we're going to use our calculator to put in our formula and let the calculator do all the skills. We're still going to find the 10th term. We're still going to find the 23rd, the 15th, the 19th, but the calculator is going to do it for us. Now, I'm going to rewrite my equation that we used, or my formula, which is a sub 1 times negative 2 n minus 1. Now, in our calculators, can we put in the letter n? We can't. We have to use x. So what we're going to do is we're going to go here, and then we're going to write our formula that's going to look just like this. Now, I'm going to give you a minute to write these down on your paper because this is what we're going to put in our calculator. We're going to the second stat, we're going to go over to ops and go to number 5, and then we're going to put in the formula just like this. So let me show you what we're going to do. So here's my calculator. So it said to go to second stat. I'm going to go right to ops and go down to number 5, which is our sequence button. So then what I'm going to do is put in our expression. Now, we said our expression was a sub 1. Well, what is a sub 1? It was my negative 2 times. I'm going to put in parentheses negative 2. If I don't put that negative 2 in parentheses, it's not going to know that it has to multiply by the whole negative 2, okay? So you have to put that negative 2 in parentheses. So let me show you. The next thing I'm going to do is hit my exponent key, and I'm going to put in parentheses now what my exponent is, which is my x minus 1 close parentheses. I'm going to press enter. Now, what variable are we using? We're using x, which is right beside my alpha key, and it says start. I want to start with my first term. I want to end with my 5th term, just so we can see how this is working. Now it says step. We are going to go step by step. So we're stepping by 1, and I'm going to press enter and enter. So make sure that yours looks just like mine. Make sure it has everything in the parentheses, and it has the x, the 1, the 5, and the 1. Now, go ahead and press enter and see what you get. Negative 2, 4, negative 8, 16, negative 32. Ms. Killen, that's our sequence. Yes, it is. I have put in my sequence in my calculator, and I don't have to find any of those terms. So how would we put in to find the 10th term? All right, let's try that. Let's go back to where we put in all that information. I'm going to go to second stat, go right to ops, and go down to number 5. Now, I'm still keeping my expression. I'm still keeping that I'm using x, but instead of starting at the first term, let's start at the 10th term, and let's end at the 15th term. because remember we had to find that 10th and 15th term. So everything looks right. We're going to press enter. My 10th term was 1024, and I'm going to scroll right. I'm going to go back up and scroll right. And this one does not scroll over to the 15th term. I do apologize for that. I do not know why. There it is, excuse me. It does, I just had to do it right. So my 15th term was negative 32,768. So let's use this same technique and find, let's see, it was the 19th term. So let's find the 19th term to the 23rd term. So here we go. Let's do second stat, go over to ops and down to number 5. Everything's staying the same except where we start and stop. We're going to start at the 19th and we're going to end at the 23rd. 19th, we said, was negative 524,288. And my 23rd term, I'm going to scroll. And we said that my 23rd term was negative 8,388,608. So all that math that we did, now it's on our calculator. Ain't that fun? All right, so let's go back. All right, so we found all of this. Now, Ms. Killen, you said that we can use these, but up here on our slide it says there's 2 ways. Exactly right, there is 2 ways. So the next one is my favorite. You may like that one, and that is perfectly fine. It works, and it's a good use tool, but the next one is my favorite. So let me show you. It says we're going to go to our y equals feature. We're going to put in our formula as y1. We're going to go to the table and look for our numbers in L2, which is our list 2. So let's go ahead and pull that calculator back up. So now what I'm going to do is I'm going to go to my y equals feature. I'm going to put in my rule. So my a sub 1 was negative 2 times, I'm putting that other negative 2 in parentheses. I'm going to hit my exponent and x minus 1. At this time, you usually go ahead and graph it so you can see what it looks like as a graph. But we're not wanting to see the graph, we want to see the table. Now, how do we pull tables? We go second graph, and there's my table. There is my first term, which is negative 2, my second term, which was 4, my third term, which was negative 8, but we're looking for our 10th term. So there's our 10th term, which is 1,024. We wanted to look for our 15th term. My x tells me what term it is, negative 32,768. Let's look for 19. Whew, now that's negative 5.2 E5. Ms. Killen, I'm not quite sure what that means. So if I light or highlight what the y value is for that 19th term, it gives it to me, negative 524,288. Now let's look at the 23rd term. Negative 8,388,608. So I have 2 possible ways to use this formula, this explicit formula for this geometric sequences. And both of them are quite easy to use. We've just got to work and repeat these processes with these different problems. All right, so let's go. Mr. Bozeman places a 5-inch long photograph in his showcase window. He enlarges the photo 10 times, increasing the length by 120% of the previous size each time. What will be the length of the photograph after the 10th enlargement? What is your a sub 1? And what's the formula? Well, obviously, let's remind ourselves, a sub n equals a sub 1. Now, we are saying that we are changing every single time by how much? It says by 120%. Now, how can I use 120% in my calculator? I turn it to a decimal. So when I take 120% and turn it to a decimal, what do I get? I get what? 1.2? All right, so I'm multiplying that 1.2 times x minus 1 or n minus 1. So let's use our calculator. I'm going to use the y equals feature. You can use either the y equals feature or go to that second stat, whichever one you want to do. So we are looking for our 10th term. And what did we say was our a sub 1? Well, it starts out at 5 inches, so it's going to be 5. So what I'm going to put in my calculator is 5, 1.2 to the x minus 1. So you've written that down. Let's go to our calculator and plug this in. So I'm going to go to y equals, and I'm going to put 5 parentheses 1.2. I'm going to raise it to the x minus 1. I'm going to go to my table, which is second graph. Now, I want the 10th term because after 10 times that it is enlarged. So let's see. I'm going to go down to my 10th term, and I get 25.79890,176. So let's just make this an easy number and say 25.8. So what we're going to put here is we're going to put 25.8. And that's what we got. See, these tools that we're learning on this calculator, they're not difficult. It's just the more we work with them, the better we are with them. All right? Now, each term in the sequence is a product of our previous term and a real number. We need to remember that. We also need to remember what that function notation looked like of our sequences and what the recursive and the explicit formulas look, how they're different, and also how we're using these calculator skills. I want to thank you for joining me here at MPB. I know that this is a little bit deeper into the math than we've been doing, but I promise you if you'll stick with me, I'll get you through it and you'll be great at it. I'm so glad you came to join me, and I want you to have a great day.